Hi, in this assignment, we have been given a task to choose the most suitable robotic system to use in Malaysia Industrial. The one we has been chosen is wheel type mobile robot. As we know nowadays, there are more manufacturing industry has been built due to the development of country. The value of robotic system has been rises. This is due to the demand of the robot system increase. The wheel type mobile robot is a one robot system which is widely used in manufacturing industrials. While there is no generally accepted definition for the term mobile robot, it is often taken to mean a device that can move autonomously from place to place to achieve a set of goals. And then the four main components a robot must have is a sensing, movement, energy, and intelligence. The environment or information is obtained by a sensors in motion control for a mobile robot. The wheel type mobile robots have better flexibility and larger workspace than the traditional industrial robots. And automated guided vehicles is one type of wheel type mobile robot, and which was invented in 1953. And this robot is most often used in industrial application to move materials around a manufacturing facility or a warehouse. The development of wheel mobile robots has been by far a most popular locomotion mechanism in mobile robotics. It provides a good efficiencies in working area. In addition, the balance is not a usually research problem in wheel robot diagram, because wheel robot always design all the wheel robot contact at all the time. Thus more than 3 wheels are used in this type robot. A suspension system is required to allow all the wheels to maintain ground contact. The minimum number of wheels required to wheel mobile robots is 2. If the center of a mass is below the wheel axis, static stability can be achieved by 2-wheel differential drive robot. There is very large space of possible wheel configuration. When one considers possible techniques for mobile robot locomotion, there are 4 major types of wheel classes for wheel mobile robot. Class A is a standard wheel, have 2 degrees of freedom, and rotation around the wheel axle and the contact point. For class B, Castle wheel have 2 degrees of freedom and rotation around the offset steering joint. For class C, which is a Swedish wheel, have 3 degrees of freedom, rotation around the wheel axle and around the rollers and around the contact point. Lastly, class D, which is the ball of spherical wheel. Realization on technically difficult. And then the sensors which is used in this type of wheel mobile robot is a 2D laser. The one we have chosen is a LiDAR sensor. This sensor has the advantage of high precision, large detection range, and fast sweep frequency. It is widely used in the obstacle detection field of the ground mobile robot. LiDAR can be divided into 2D LiDAR and 3D LiDAR. In this assignment, we focuses on the 2D LiDAR for its low price and more fast processing time. The most commonly used local obstacle avoidance method is artificial potential field method and visible graph method. They are all provide most advantages of a simple mathematically model and good real-time performance. The theory of artificial potential field was proposed by Khatib. He defined the influence of the target on the robot as a virtual attractive force, and the influence of obstacle on the robot as a virtual repulsive force. The direction of the resultant force is also direction of the next movement of the robot. The traditional artificial potential field method has some problems, such as local optimal solution and target inaccessible when robot is near to this target. There are some improved artificial potential field methods combined with the fuzzy rules, genetic algorithm, and regression search method, respectively. The visual graph method can be used to judge if the line between the mobile robot and the target cross the obstacle. No cross represent the target is visible. The robot can reach the target point directly. Otherwise, choose one of the connecting line from a robot to the end of obstacles at the direction of traffic. For LiDAR sensor, it has a measuring distance up to 80 meters, and the horizontal scan ranges from -5 degree up to positive 185 degree. The angle of resolution is set to 1 degree. For in a single scan, they have 191 laser point. And then, since the LiDAR is in a single plane scanning, considering the LiDAR is installed on a ground mobile robot, may encounter low obstacle. Install the LiDAR in a slightly downward sloping way. When use it, set the sloping angle as A. As we can see in this diagram, on the left, bottom left, the obstacle is on the ground and the LiDAR is on top of the robot. The sensor angle is adjust to lower a bit, and then the bottom right is a laser point in a single scan. And then the second for the second sensors we have used in this wheel type mobile robot is the cameras. According to the pinhole camera, the acquisition module encapsulates all the intrinsic parameters of the cameras and the function to obtain distorted stereo image. The system does not rectify the image, and thus it does not need the extrinsic parameters of the stereo rig. In order to implement an efficient color segmentation module, color edge detection was applied as a preliminary step to detect the boundaries between the observed surface. Similarly to other approaches, a group of researchers has the implementation that perform the following operation. For the first, median filtering to lessen the effect of noise-preserving edges. image gradient computation for every channel through a derivative kernel or other operators. For the second one, sum of the norm of the gradient 6 components x and y and every channel for every pixel to provide a faster execution. And then the binary thresholding, in order to set to strong edges to 0 and the inner region to 1 to obtain binary map can be then easily labeled with block detection algorithm. Okay. For 3D reconstruction, the cameras and the robot reference system can be chosen like in two cameras are displayed only along the x-axis of the robot coordinate system. In an ideal case, this system of equation provides the intersection between the two lines, starting from the camera's origin, passing through the points on the image planes and reaching F. However, since disparity in estimation, angle measurement, and the pixel quantization introduce errors, these lines may not intersect at all. Thus, two PID controllers were designed to control linear and angular speed using the linear distance and the heading difference as error function. The robot state, position, heading, direction, and camera's angle is constantly updated by a dedicated thread which reads the encoder and computes the new state for every iteration. In this way, an update routine runs in the background, supplying the whole system with a constantly up-to-date state of the robot. This is a bill of material. The component we have used in this design is a wheel, LiDAR sensor, microcontroller, robot structure, receiver and transmitter, battery, LCD screen, and camera. The total cost is around 2,220 ringgit. And then the sustainability of this wheel type mobile robot is to reduce labor costs, improving productivity, and which better floor space utilization by decreasing a footprint of work area by automating part of the production line, which can utilize the floor space for other operation and make the process flow more efficient. Reduce the waste. Robots are so accurate that the amount of raw material used can be reduced and decreasing the cost on the waste. And increase the safety of the manufacturing. Robot increase the workplace safety. Workers are moved to supervisory roles where they no longer have to perform dangerous application in hazardous setting. And then that's all for the presentation.